All right, guys, so this is one of our last videos before probably the next Canvas assignment is coming up. And we just talked about a couple of different definitions. And some of these definitions were called saturation. One was preconditioning, one was evaporation, and the other one was the formation of a secondary front. And here's an image that I would like to share with you on maybe a visual representation of what we're talking about here. And it's going to allow me to go into a little bit more detail versus just kind of the basic straight up definitions that we've discussed. So the first one is saturation. So in the very first image that you see on the left, saturation is taking place. So what you're seeing down here at the very bottom is a mobile phase. And keep in mind that this is a double trough or a twin trough chamber. So a twin trough, and a twin trough chamber is typically called a TTC, twin trough chamber, or a double trough chamber. But I'm seeing some mobile phase here on the back end, and I'm seeing some mobile phase here on the front end. But I've got mobile phase there in the bottom. That's all that matters. And then that mobile phase is probably a mixture, or developing solvent is a mixture of two different solvents. So who knows where they're calling them A's and B's in the diagram, and that's perfectly fine. That's not a big issue at all. And then on the back side here, I'm seeing a piece of filter paper. They've called it filter paper, but actually this is more formally termed a saturation pad. So that saturation pad is going to be placed into the tank. And the purpose of that saturation pad is to take some of the mobile phase or developing solvent that we have placed into the back area of the tank, and that saturation pad is going to be lowered down on the inside of that particular developing solvent, and it's going to start sucking it up just like a regular piece of paper would. So what's happening is that developing solvent is getting sucked up, and there's a very thin film now of that developing solvent across that saturation pad, and evaporation is starting to take place. So we're starting to see some of the volatile components leave that developing solvent, and it is helping us to create this gas phase that is staying in the upper realms of the chamber. So this is our saturation step. So if we're using a machine, and that machine is an HPTLC instrument, there is very often a saturation step that we can talk about, that we can do some settings on, and this is the step that we are referring to. So for the most part in HPTLC, the saturation steps are going to be, give or take a little bit, 20 minutes. So that is normally what we kind of see in the methods. That's what we're going to set in our computer software. So that way we can tell the instrument, dump the developing solvent on the bottom, put your saturation pad in there, put a lid on it, and just sit there for 20 minutes. Just sit there. Don't do anything at all. You just look at me and you smile. That is what goes on in the saturation step of the HPTLC instrument. Okay, so after the saturation, the purpose of this is to create the gas phase. So I've got the developing solvent in the bottom that is creating a gas phase. My stationary phase will be on the plate. All right, so we got that covered. And then when the plate gets lowered in after those 20 minutes, when the plate gets lowered in, if it goes ahead and dunks down into that developing solvent, then whatever is left over at that moment in time after 20 minutes, that is more properly my mobile phase. So the mobile phase starts to get sucked up by the plate, and it will begin to start moving my components through the stationary phase, and I start to see separation that happens. All right, so that's great. That's what I want to use TLC for. All right, so next up is preconditioning. And I told you that there's kind of a quick way that we can do this by hand. I mean, I can't just dangle by hand the plate in the gas phase because I'm going to have an open lid, and there's no easy way for me to kind of self-contain it if I'm going to do this by hand. So what goes on if I want to precondition the plate by a manual type of method? Very easy, quick trick, and this is what I referred to in that video. Again, this chamber is a twin trough chamber. So I'm seeing a back trough and I'm seeing a front trough. So what you're going to see if preconditioning is going to be involved in a manual method, you're going to see some mobile phase or developing solvent that goes here in the very back. That developing solvent is going to do what developing solvent always does. So there is going to be a saturation pad on one side of the tank, typically on the back side. That developing solvent is going to be poured only in the back trough, and that is it. That trough goes all the way down. It divides those two sections all the way down the chamber that you're using. And then it's going to do what it's always doing. That saturation pad's going to suck up that developing solvent, and then evaporation is going to take place off of the saturation pad, and I create a gas phase just like I did in the very beginning. That is not an issue. Okay, well, after that 20 minutes is over, there is a chance that I want to do some preconditioning. Okay, or maybe the method tells me to precondition it during that 20 minutes. So just allow that gas phase to generate and allow that gas phase to come in contact with my silica and the stationary phase just right then and there. Just go ahead and do it. And if so, that's great. That's what we'll do. Again, I'll just follow directions. I'll follow SOP. All right, so normally what would happen in this case is that there is no developing solvent in the front trough. Notice how this is made. There's no liquid there at all. I've got my plate, my silica plate, that has been inside of the tank or been lowered inside of the tank at some point in time. And that plate is not sitting in developing solvent. So nothing is moving through the silica. Therefore, there is no mobile phase at this point. No separation is taking place at all. But that plate is being exposed to the gas phase that is being generated by the saturation pad. So whatever volatile component is up here, it's going to start hitting the surface of that silica. And as it hits the surface of that silica, it is somewhat preconditioning that area of the plate for the analysis that will initially take place after I begin to add the developing solvent to the front trough. Next up is C. So C is the idea that evaporation is taking place. And I told you evaporation is taking place everywhere, but evaporation is also taking place on the plate as it begins to develop and before it begins to develop. So in the preconditioning phase, there is a chance that I'm beginning to see some evaporation that will take place off of the plate. So if things are latching to it, things are still volatile, they can still escape. That's not a problem. There's evaporation. Evaporation still taking place on the saturation pad. It's still sucking that developing solvent up. Things are still evaporating off. Things are still creating the gas phase for me. That's not an issue either. But evaporation can also happen on the plate during the development. So as the plate begins to develop and as this mobile phase begins to suck up the plate, we start to see separation, and I see those colored squares that are there on the plate. What I'm beginning to see is that mobile phase, because that is proper mobile phase at that point, that mobile phase still has volatile components. It has not went anywhere. It is still present. It's still there. So if it's evaporating everywhere else, it's going to be evaporating off of my plate as well. So that's why I'm seeing I'm starting to see evaporation off of the surface of these plates. So that's why I see kind of the colored circles that are there, because that means that that mobile phase is evaporating off of the surface of the plate as it begins to travel up and up and up and up and up. This is also one of the reasons that it takes a little bit longer as we go higher and higher up the plate with the mobile phase. So in the beginning, it's like, oh my gosh, look at how fast it's going. I'm going to be done with this in 15 minutes. And then you come back in 15 minutes and things are barely moved. And the reason is because as it's traveling up, there is a very thin layer of mobile phase that is present on that stationary phase. So it is way easier for it to evaporate off of the plate at that moment in time. And if that is the case, and if that's what's going on, well, it's going to take a little bit longer to go in the upper parts of the plate, because we've got to make sure that it doesn't evaporate off quickly. And over time, as the plate becomes more and more saturated, as there's less and less spots for it to kind of evaporate off, then we get this kind of quicker development that takes place in the upper parts of the plate. But by no means necessary. I mean, in all situations, for the most part, there's no way that I can speed that reaction up. It is going to take slower and slower time for it to reach the top of the plate as it develops longer and longer. There's things that we can do to help kind of shorten those time lengths down, but it's going to happen. And I just got to accept that, and I just got to go with it. And my instrumentation will take over. My manual methods will slow down. I mean, that is just a thing that's going to happen. But it's going to take longer and longer, and that is why it's due to the evaporation that is taking place in the upper parts of the plate here. Next up is the formation of the secondary front. So here's the formation of the secondary fronts. So I've got this developing solvent in the bottom, and then now it's turned into proper mobile phase because it has been sucked up the plate, and then I'll start to see the separation that begins to happen with our components. That is great, but there is a chance that one of my components will travel much faster than the other component of the mobile phase. So here is the line that I would see on the plate for a secondary front. And this one is called the primary front, just because it says secondary front number 2. But we're going to call this the primary front. And the reason that I call it the primary front is because that is probably where we're going to be measuring our RF values from. Let's just say that that is exactly where we're going to stop it. That is how high that mobile phase has reached on the plate. That is my proper stopping point. That is where I'm going to be measuring my retention factors from. So with that said, that's going to be my main developing line that I'm going to be using for all of my calculations. However, on the developing side of the house, when I begin to look at these plates, I could see another line that goes all the way across. That is not contamination. That could be just a secondary front due to the solvent component that is not traveling as fast as another component in the developing solvent that you have made. All right, so notice that all of these are kind of illustrated separately, you know, A and B and C and D, but all of these could be going on at the same time, folks, right? I've got saturation that's going on. I've got the saturation pad that's in there. All of that evaporation is taking place. That gas phase is actually doing what the gas phase is supposed to do. I've got a plate that is now being possibly preconditioned. Nothing is going on, and then I get some evaporation off of that plate as well, but the upper parts of that plate will be exposed to gas phase no matter what. Even during the run, the plate is going to be exposed to the gas phase that is in there at that moment. And then in evaporation step, I'm going to get things that leaves that plate during the development. It's just natural. That's what they do. They're very volatile. They evaporate off quite easily. And then C is the formation of the secondary fronts. So this is traveling up the plate in real time as all of these other things are happening as well. So even though they are drawn separately, it's really just to give you an idea of the specifics that each one of these terms represent. But they are all happening at once, and they will continue to happen until I take the chamber and the plate off of the instrument, or until I take the plate out of the chamber by manual methods. But all of these things are going to be happening for sure. All right. Okay, so with that said, that's going to end probably that next assignment that you're going to see within Canvas. So in the next one, we are going to focus on more of the sample preparation and talk about what goes on with proper sample prep. What should we be doing? How should I handle it? What type of solvent should we be using? But again, I think we are taking baby steps. That is the most important thing of the overall idea before I start talking about pieces and instrumentation and those types of things for sure. All right. So with that said, good luck on the assignments. I hope that you have taken a lot of notes, and I hope that you understand all of this without a problem. And if you paid attention and you watched me on double speed and you've not really been distracted with your phones or what's going on the TV, and I'm just background noise, then I think that you'll do pretty well on the assignment. So good luck, and let me know if you need some help.